without further ado, let me start with our first speaker, Serge Wich. Did I pronounce that correctly? Excellent. From Liverpool at John Moores University, a primatologist who's studied many aspects of orangutan behavior and ecology for almost 2 decades. He's also involved in applied conservation research throughout the orangutan range, and his presentation will deal with the application of a new technique to support conservation. Please welcome Serge.
Thank you very much, Mary. Thank you very much for still being here. I'll try to speed up a little bit so that I don't keep you away from your food and drinks. So I'm going to talk about drones, and an important question is always, what are drones? Well, they're not male honeybees in this context, neither are they creepy alien life forms. We are talking about robotic planes or unmanned aerial vehicles, UAVs, and unmanned aircraft systems. If you Google drones, you mainly get pictures from the military application of drones. As we all know, there's a little bit of a negative connotation with the word drones. But they also have a lot of civilian applications. They're used for search and rescue, they're used for industrial agriculture, filmmaking, research, and also for entertainment. But what about drones for conservation? We started this project, Lian Pin from the ETH in Switzerland and myself a while ago, almost a year, but we've gotten quite some attention, so there seems to be quite some interest from the conservation community for potential application of drones, if you have to believe the media reports of the work we're doing. But why did we start this? Well, we started this because there's an urgent problem. There's a lot of habitat loss and conversion. This has a lot of impact on apes, such as orangutans, and we're not always able to keep track of those changes because they happen so fast. And the way we traditionally try to keep track of changes is either by satellite images of area, and for orangutan populations, their density and distribution, we do a lot of ground surveys. So for instance, we've just finished this 3-year survey in Sumatra, great design, many areas we covered all throughout the range, but it's very costly and it takes 3 years, and it's probably not something we'll be able to do every 3 years. So there must be other ways we can try to get a handle on where orangutans are and how many of them are. And orangutans, fortunately, like other apes, make nests. They make them fairly high up in trees, so maybe there's a way to detect those from the air. The other issue is that for a lot of the habitat changes, we use satellite images. Free satellite images are fairly low resolution, although they're updated very often. High resolution images are quite costly still, and they're also not always in the time sequence that you would like them to be, because often you would like to keep track of an area where changes are occurring every week or every month with high resolution images. So that's what we were thinking about when Lian Pin and I talked about drones. What if you can use a little plane to fly over a forest and take pictures of nests and the forest to give us some of that information? So we looked for some seed funding. Unfortunately, there were funders to put some money into this rather risky idea, because nobody knew whether it was going to work. So we went shopping, but commercial drones are really quite expensive, and ecologists don't have much money. So we thought, okay, we have to try to look at something else. And fortunately, the internet is helpful for that, and it provides some information also about other drone systems. This is an American Army drone system, and it also taught us that it's quite costly to maintain, so we decided to look for a do-it-yourself solution. There is a large community called do-it-yourself drones based out of the US, but there are people that are involved in that globally, and they provide a lot of information on how you can build your own drone. So we decided to do that. So you buy stuff from hobby shops and some electronics, and you read on how you put it together. And so we made our first prototype, a very cheap Chinese plane, a nice little GoPro camera on it, and we tested it in Switzerland. Just one flight over forest areas, in a snow area, and then we were ready to go to the tropics. So that's Leon Pin in the front and me in the back. We took a small pirogue to a forest area and launched it there, and it worked really well. We got some footage from the GoPro camera. So this first test was really quite successful. So then we launched a website to share our ideas and our knowledge on this system to others. And we did that in April, and we have almost 40,000 hits already. So it's something that apparently people find very interesting. So we started to continue the development and look for applications of this. But first, let me quickly explain you how it works. Basically, you have a program, you get a Google-like map, and you program the waypoints on that map. So if you just want to fly to certain locations, you program those points on the map. If you're interested to really map an area for land cover, you can make a grid, and you load this information up to the autopilot in the plane, and you launch it by hand or by catapult, and it flies that route, and it will land. And then you have the information from either your camera or your video camera. So what are they really good for? Well, we look at them as a super low-cost remote sensing tool, because that's in a way what it can do. So you can look at ecosystem level patterns. For instance, here in Saba, you see a mixed forest there with lots of species, and as you move to the Oxbow, you see a uniform tree stand, so it can provide information on those kind of things. You could look at tree level phenomena. The resolution of these pictures can be about 1 centimeter per pixel. So you see fruits, you can recognize some species that have large leaves. So there's a potential for those kind of applications. You can see orangutan nests with them. You can see human activities such as logging. You see the planks lying there. You can see agriculture. You can count how many oil palms are planted there. You can actually take pictures of animals themselves. Picture of an orangutan, an elephant, some rhinos in Chitwan National Park in Nepal. You can make mosaics from these images, and you can geo-reference them and use them as a layer in geographical information programs like ArcGIS or any other program, so it can help you to look at land use. You can make three-dimensional images if you have enough overlap between photos. This is just a very this is from a flight that wasn't really meant to do that, so the overlap between the photos wasn't that great, but it gives you a little bit of an indication of what you could do. And there's nice software to do these kind of things, so you can do flights with more overlap to get even more information on your systems. You can put a high definition video camera under it. We use GoPros and contours. They give you a nice bird eye view of the landscape, so it gives you really beautiful information. It can also be used as an eye in the sky. Here you see two places where there's smoke, so you can use it to potentially fly over forests and find out where there's smoke, potentially from poachers or other people that are doing activities in forests, and then you could potentially send people in to check on what people are doing there. From that early model, we moved to some new models. This is our last model, or latest model. Here are some of the specs. Here you see it flying. It can take a payload of about 1 kilo, so you can put a Canon camera for photos and a video camera in it in the same time. It's guided by GPS. It can land automatically in quite a small area. We're testing live telemetry, and that's working quite well. We're trying to get it up to a longer range. We have now a system that works up to 3 to 5 kilometers and gives you a live video feedback on what's being seen by your camera. So it's really helpful to make response time much faster if there's something you really want to detect in the field and react to it. As I said, you get high resolution pictures from it and video. This model can fly about 40 to 60 minutes depending on how high you fly, wind, etc., which translates into about 30 to 50 kilometers. And the rough cost to build such a system is $3,000 to $5,000 depending on what the specifications are that people would need. What are ongoing developments? Well, what we would really like to see is to work with engineers to see if we can turn a drone into a data mule for camera traps, for radio collars potentially, so you don't need to walk in with these antennas into a forest anymore. So it would provide that information to your computer wherever you are. We're also working with computer vision people to do object recognition. We're testing that on orangutan nests and something easier, cows in a Dutch grassland. So that would hopefully lead in some time to automatic detection of nests and then a density estimate for the area that you flew over. Thank you for your attention.